Hello people, my name is Jeff and welcome to my channel. So let's dive right into the business. Today we're going to explore and actually code an interior design assistant, mainly focusing on empty room decoration. Our AI assistant will work by taking an empty room image as well as the type of the room we want to create the design for. We will also allow the human to provide an image that reflects the desired style of the design, along with any other design requirements the human might have. For example, specific furniture pieces the human wants to include into the design or overall layout of the room. Using this information, the assistant will generate interior design proposal and eventually visualize it. In order to achieve such functionality, we will be leveraging a collaborative agents approach in conjunction with an Autogen library. For image generation, we will utilize open source stable diffusion AI models. We are going to create our own image generation workflow using the ComfyUI interface and then host it as an API, allowing our visualization AI agent to call it to perform the actual visualization. Our collaborative agents will employ the OpenAI GPT4-V model to generate the initial design proposal as well as to review the generated visualization and how it corresponds to the initial design to provide necessary adjustments and improvements. We will also create a small UI for debugging purposes using the Streamlit Python library. So before we begin the implementation, let me share a few words about how stable diffusion models work. A short disclaimer, I am not an expert in the stable diffusion area. In fact, this is my first attempt at using stable diffusion models to prototype something which can potentially be useful. However, if you are interested in this topic, I strongly encourage you to look for additional info and learn about it on your own. I will leave some useful links in the description below. Okay, so before stable diffusion, the standard way to generate images was using generative adversarial networks. Essentially, you start with a pseudo-random noise and pass it through a large neural network, the generator network, which performs the denoise operation and produces potentially high-fidelity images. Concurrently, there is another neural network, the discriminator network, that must determine whether the image was produced by the generator network or if it's a real one from the training dataset. Half of the time, you feed the discriminator network the real images, and sometimes images produced by the generator network, so it trains and gets better at classifying the images. Meanwhile, the generator also learns and improves at producing images that are classified as real ones. This method works, but it's complex and can be unstable during training. For instance, if the discriminator classifies an image as real, the generator network might repeatedly produce that same image since it's a full discriminator network already. So the generator network stops evolving because it basically achieved its goal. And if you think about it, intuitively producing a high quality image from a random noise in one go can be quite a challenging task to do. On the other hand, the stable diffusion suggests splitting the denoising process into several smaller steps and running it in a loop. Here is how it works. You start with an image, and on each step you add a bit of noise to it based on the schedule. So at the end you just have noise. Then we can use this data to train the model to undo this process, but not in one go to get the initial image, but to undo the process between subsequent steps. It is important that during training, we train our model on many copies of the image with different amount of noise, basically using the images from the different steps. So it's able to denoise really noisy images as well as slightly noisy images. The key thing here is that we train our model to predict how much noise was added into the image at the specific step. For example, if we have an image X at step t equals 10, we can ask the model to predict the amount of all the noise added into the image. We then subtract this noise from the image to get the estimate what the original image was. This image won't look very good for the first iteration and will still have some noise, but what we do next, we add back some of the noise, not all of it, but some. And then we get image X with the level of the noise, which roughly corresponds to the noise level at step t equals 9. So we have slightly less noisy image. And then we can repeat the process by providing this image as an input. So each iteration gets us a bit closer to what the model thinks was the original image. But the question is, how do you guide the model to produce what you actually want instead of a random image? And the answer is that we condition our model by giving it access to the image text description. Basically, during the training process, the text and the image pairs, for example, this picture of the sofa with the corresponding description, are encoded into high-dimensional vectors using a transformer-based text encoder and an image encoder respectively. The model is then trained using a contrastive learning approach, or CLIP, technique which was introduced by OpenAI, where it learns to minimize the distance between vectors of matching text-image pairs and maximize the distance for non-matching pairs. In simple words, the model is trained to produce the same output for the matching text-image pairs. This process effectively teaches the model to accurately align text description with the corresponding visual content. From the other hand, during the image generation process, the trained model uses the text prompt embedding to guide the denoising process. Basically, it adjusts each step based on the embedded text through a clip-like mechanism, shaping the final image to reflect the textual description accurately. Okay, this was hard. As I already mentioned, I strongly encourage you to read this information on your own. But let's get back to our interior design AI assistant. Our AI assistant will consist of two main agents, interior designer and interior visualizer. This agent will collaborate with each other in order to provide client with the best possible interior design. Interior design agent will be responsible for generating initial design proposal based on empty room image, reference design style image, and specific requirements the client can have. It will also be responsible for reviewing the visualized design, which was generated by interior visualizer agent, and provide detailed feedback focusing on how closely the visualization matches the initial design proposal, and then suggest specific adjustments to better align the visualization with the original design concept. To make this happen, our design agent will heavily rely on OpenAI GPT4 Vision model. From the other hand, the interior visualizer agent will be responsible to convert detailed design description generated by interior designer into simplified and effective prompts suitable for image generation systems. Then it will perform a call to our image generation workflow, which will be hosted as an API to generate the interior design visualization and return it back to the interior designer agent for review. The process will continue until the visualization is at least 95% accurate to the initial design. Then the process will be terminated. For our image generation workflow, we will utilize open source stable diffusion models, as well as ComfyUI interface to create our generation workflow. At the end, we will create a simple Streamlit application for debugging purposes. That being said, let's move into the code and get our hands dirty. Okay, so we are inside our Visual Studio Code. Our empty interior designer solution is open. The Autogen library is installed on our virtual environment, so let's start creating our agents. So we begin by introducing two helper agents. The first one is the client proxy agent, which will be used to represent our client who wants the best interior design possible. And another one is the code executor agent, which will be used for our Python code execution. For both of the agents, we set human input mode to never, because we don't want humans to be able to interrupt our interior design generation process. A short disclaimer: if you want to understand how classes from Autogen library work, including the user proxy agent class, I suggest you to watch my YouTube AI assistant video, where I explain it in much more details. I will leave the link in the description below. Our client proxy agent will be able to terminate our agent's collaborative work, when it received terminate message from the interior designer agent. It will happen when our interior designer agent, after reviewing the visualization, finds out that it is 95% accurate with the generated initial design proposal. In this case, our interior designer agent will append word terminate to its message. And that's what our client proxy will use to terminate the process of collaboration between our agents. The code executor agent is really basic. We just provide code execution configuration by setting code execution config section. Now let's take a look at our interior designer agent. As you can see, the agent is also quite basic. We just provide the custom system prompt to it, where we define two main areas of agent responsibilities. The first one is to create initial design proposal based on empty room image, as well as a reference design style image and the client requirements. And the second one is to review the generated visualization and provide detailed feedback, focusing on how closely the visualization matching the initial design proposal. And the last one is the termination instruction, which say, if the visualization is at least 95% accurate, then the agent should complete the task by saying word terminate. The most interesting thing here is how do you apply the vision capability to our interior designer agent to be able to review the generated visualization. And here you have two options. The first option is to use multi-modal conversible agent class from Autogen library, where you can pass GPT4 Vision model and then your agent can use it. Unfortunately, I didn't succeed using multimodal conversible agent class in my group chat conversation between designer and the visualizer. So I go with the second option, which is to apply vision capability to your agent explicitly. In order to do it, you first import vision capability class from Autogen library. And then you construct your vision capability object by supplying it with the GPT4-V model configuration. If you look at my LLM config4v configuration object, you will notice that I'm basically filtering my OEM config list file by the model name, which is GPT4V in my case. And then I'm attaching vision capability to my interior designer agent by calling add-to-agent method. In fact, vision capability class is quite clever and flexible way to attach vision to any of your agents. For example, if you have existing agent which is using Mistral large language model, and then you decide to supply it with the vision capability, which can potentially use GPT4V model or even Grok Vision. So vision capability class allows you to do it. Okay, let's take a look at our last agent, which is interior visualizer. In agent system message, we define two main areas of agent's responsibility. The first one is to visualize the design. In order to do it, the agent converts the detailed design description into simplified and effective prompt suitable for image generation systems. And then use the simplified prompt and the reference photo to create a visualization of interior design. The second one is to adjust the visualization. So agent will continuously refine the design visualization based on the interior designer's feedback, and then modify the simplified prompt as needed to achieve the best possible result. The key difference here is that our interior visualizer will have access to the function create interior design visualization. This function will be called each time interior visualizer wants to create the visualization by passing empty room image URL, design style image URL, and then the simplified design prompt. Create interior design visualization function will call our custom stable diffusion image generation workflow, which we will host as an API, and then return back the URL of created design visualization. This image URL will be passed back to the interior design agent, so it can get access to the created visualization to start the reviewing process, and provide its feedback to the visualizer agent back if needed. For now, we will leave create interior design visualization function implementation empty. We will get back to it when we implement our own custom image generation workflow using stable diffusion models and ComfyUI interface. A quick note, here I am using register function from Autogen library. If you want to get more details on how a register function works and how our method or tool became available to our agent, I'm again referencing you to my YouTube AI assistant video. Okay, our next step is to generate our custom image generation workflow. In order to do it, we will use ComfyUI interface, which allows us to design and actually execute advanced stable diffusion workflows using a nodes-based interface. I'm not going to explain you how to install ComfyUI on your local computer. There are plenty of articles on the internet as well as YouTube videos. My personal opinion that you should use Stability Matrix Package Manager UI for stable diffusion. It's completely free and will simplify the process significantly, especially if you are on Linux or Mac. I will leave the link to the Stability Matrix project GitHub in the description below. Okay, so let's start creating our custom image generation workflow in the ComfyUI interface. We will start with the basic stable diffusion image generation workflow and then adjust it based on our requirements. So the first thing we have to do is to add our main stable diffusion model, which will be used for denoising. So I double click the surface and search for the node, load checkpoint. Then in the drop down I select my stable diffusion model. Regarding the models, there is a huge variety of open source stable diffusion models. For example, you can go to the civitai.com page and try to search for the model you are interested in. I personally search for the interior design images first, and then in the image description you can find what model and with what parameters was used to generate it. So I will use this one, Realistic Vision. You just download it and then put it in the checkpoint folder. That's how ComfyUI names the models, inside your ComfyUI installation folder. That's it. Then we have to add our empty room image reference. So we have some image to test our workflow with. For this I will use the node load image and then select the needed image from the dropdown. The next step is to add our text prompt placeholder, which, as we already discussed, will guide the process of denoising and condition our model. In ComfyUI you have two prompts, the positive one and the negative one. First represents something you want to see in your final image. The second one represents something you don't want to be in your generated image as a result. Now, for testing purposes, I will put here a random interior description, which I want my workflow to generate. The core of any workflow is the case sampler. The case sampler uses the provided model as well as positive and negative conditioning to generate a new version of the given latent. First, the latent is noised up according to the given seed and denoise strengths, erasing some of the latent image. Then this noise is removed using the given model and text prompt conditioning, basically dreaming up new details in places where the image was erased by noise. Okay, but let's talk about what the latent is. Well, how I understand it, instead of working directly in pixel space, the stable diffusion model compresses the image into a latent space. The latent space is significantly smaller, making the model faster and more efficient. So in order to generate the latent space or image from the latent space, special encoders and decoders nodes have to be used. Let's add them and connect our workflow. So I add encoder node to convert our image into latent space and then provide it to our case sampler. We have to provide variational autoencoder to this node, so I will use this one, which, how I notice, is the most used one. Then we connect our model with the case sampler, our text prompts as well, and pass the latent space. We also have to decode our output or latent space from case sampler into the image and then preview it with the preview image node. That's it. Let's run our workflow and see what it generates. Okay, as you can see, our workflow produced interior design based on our text prompt, which is good, but most probably not enough for us. We would like to condition our model to correspond to our empty room layout. This can be done by using the ControlNets. ControlNet is a neural network that controls image generation in stable diffusion by adding extra conditions. For interior design, we would like to control the shape of our empty room. To do it, we will use MLSD ControlNet, which stands for Mobile Line Segment Detection, and we pass to it our preprocessed image. We will use MLSD preprocessor as well, which is capable to detect all straight lines in our image, which should be enough to preserve the shape of the room. Let's implement it in ComfyUI. So first one is the preprocessing part. Then we load the ControlNet and then apply it to our preprocessed image, passing our text prompts. I will also add preview image node to see the result of our preprocessing. Let's adjust the strength of our ControlNet and run our workflow to see how the output was changed. Great! Now our workflow takes in consideration the shape of our room. Our next requirement is to use a reference image with the design style the client wants to have. To do it, we will use IPAdapter or image prompt adapter approach. In few words, IPAdapter is a stable diffusion add-on for using images as prompts. You can use it to copy the style, composition or face in the reference image. I will leave the link in the description below if you are interested in the details. Before we proceed, a short disclaimer. In our image generation workflow, I am using some of the custom nodes and preprocessor, as well as control nets and models, which you won't get out of the box when you install ComfyUI from scratch. In order to install them, you have to use ComfyUI Manager. So you just go to ComfyUI Manager GitHub page and just follow the installation instructions. After that, you can use ComfyUI Manager to install IPAdapter Plus add-on as well. So you have all IPAdapter nodes available. Okay, first you need to load an IPAdapter. Then prepare our reference style image, which will load by using load image node and then apply all this to our stable diffusion model. We also have to select the style transfer option in the weight type dropdown. Let's adjust the strength of our IPAdapter node and connect it to the main workflow and try to run it. As you can see, our style was successfully transferred to our interior design. Great, we have our custom image generation workflow ready to be hosted as an API. To do it, we will use replicate.com. Fortunately for us, replicate.com already allows running ComfyUI workflows as an API. You have to go to Explorer section and then search for ComfyUI. This will give you any ComfyUI workflow template, which you can use to run any ComfyUI workflow. To use this template, first you have to create an account on Replicate. They will give you some free credits, actually not a lot at all. I was able to run only 5-10 executions, then I have to add my credit card. After you created an account, you have to install replicate.com Python package and then obtain personal API token to access an API. Okay, great. Now we're ready to switch back to our interior design AI assistant code and finalize our create interior design visualization method implementation. The implementation is quite trivial. We import replicate from Python package and then construct an input object which will be passed to replicate.com API to execute our workflow. The main thing here is that we pass our custom image generation workflow with each API call for replicate to execute it. We will look at getFormatted image generation workflow method implementation just in a minute. Then we run any ComfyUI workflow template by calling replicate.run method, as you can see here, by passing input object as a parameter. The first item in the response will be an URL of the generated image. Here I am using special syntax, this image tag, which is supported by Autogen Vision capability class, so it can detect and then load an image presented in the text message from the given URL. And this is precisely what our interior designer agent will do in order to start the reviewing process. Okay, now let's take a look at getFormatted image generation workflow method implementation. I extracted it in a separate file. Before implementing, we need to get API version of our ComfyUI image generation workflow. To do it, we have to turn on the Enable Dev Mode options from the ComfyUI settings, and then use Save API Format button to save our workflow API version. Then we can simply take Save JSON object and paste it to our implementation. To finalize the implementation, we have to replace our empty room image URL, reference style image URL, and the positive prompt text value with the method parameters values. The last thing we have to do to make this method work is to add our replicate API token to the .env file, and then we're done with the implementation. So to make our agents start to collaborate with each other in order to provide client with the interior design image, we have to create Groupchat for all our agents and then define the Groupchat manager. And this is precisely what we're doing here. Before we start using our interior design AI assistant, we will create small Streamlit app. You have to install Streamlit Python package for this, so we can debug the process. I won't go into much details about the code, because I guess this app is hardly related to the main application. Moreover, you can find all the code in my GitHub. But basically, after client provides all reference data and click generate button, we are making call to our helper function interior design for, which initiate our group chat by sending all the needed data to our agents. As you can see here, I'm again using the special syntax image tag, so our agents can pull the images from the internet. Let's run our app by using Streamlit run app.py command and then explore the results. So first, let's take a look at our agent's message log. As you can see, our client proxy initiates the conversation. Then our interior designer generates the initial design proposal based on the provided reference data. The visualizer agent accepts the design proposal and then converts the design idea into a simplified prompt and calls for our visualization method, which was executed by our code executor agent. From the other hand, if you look at the generated images, you will see that something strange is happening, because we achieved the best result on the first iteration. Basically, when our visualizer generates the visualization from the initial design proposal. Well, to be honest, I think it's because the stable diffusion model I am using. Most probably, I need to search for the model which was primarily trained for the design interior, because now I am using realistic vision model, which I guess was trained on human photos. So the enhanced prompts confuse the model. Another approach is most probably to integrate the LoRa model into our ComfyUI workflow, which was trained specifically for the interior design. But then we have to check if any ComfyUI workflow template from replicate.com supports it. Otherwise, we won't be able to run it. Anyhow, you can find all the code in my GitHub repository. I will put link in the description below so you can experiment on your own. That being said, thank you for watching and see you next time. Bye!